Hello, 8th grade math students. Mr. Lawrence here, and a special welcome to any of Mr. Wenma's students that might be listening. You may not have seen this before, but I make videos for my students. Hannah Friedline asked for this one. She was having a little trouble with a homework assignment we did, and Mr. Wenma's class and my class are in about the same place. So I'll be making a few videos along here, and so if you like them, you're welcome to check them out and use them. Help you be successful during this time period. Okay, so in case you didn't know, we're going to be having lessons on Monday the 16th through the 20th, and we're going to take the break off, the spring break that we were supposed to have, and then that following week we'll be having lessons again. Okay? So I'll be making videos, and there'll be digits assignments and all that kind of stuff to help you along as you go. And I think Mr. Weinman said he was going to share something with my students that I've never done before, but I guess his students really like. I don't want to say the name. Mr. Wemman's students know what I'm talking about. But anyway, we'll check that out next week. All right, so here we go. Now, by the way, you see this website here? Mr. Wemman's students, if you don't know this website yet, I would get on it and favorite it on your homepage. Save it to your, not to your homepage, but you know what I'm trying to say, on your Chromebook. Save it, because it is super useful in checking graphs. I'm going to show you how to do this on each graph. So I've got 6 graphs here I'm going to do. All right, now remember, we're graphing from slope intercept. That's the only way you know how to do it. The algebra kids know different ways to graph. You only know slope intercept form. And if you work hard at this year, when you get up into Algebra 1, this will be a cake, and then you'll have an easier time learning the methods next year. Okay, so I look, am I in slope intercept for question number 1? It says y equals negative 2/3 x plus 5. And I am. How do I know? Because y is alone. The y must be alone. And when y is alone, that means I'm in the form y equals mx plus b, known as slope intercept form. And the coefficient of x is my slope, and the y-intercept is the number that's added or subtracted from x. Okay, so that's the y-intercept. So since I am in slope intercept form, I can find my y-intercept, also known as b, right? Y equals mx plus b, and in this case it's 5. And then my slope is negative 2/3. Okay, now remember, only one of those can be negative, because if you make them both negative like this, negative 2 over negative 3, the two negatives would cancel out, making it a positive fraction. And it's clearly not a positive fraction. So don't go changing the number. Don't do that. It makes it confusing. All right, so I need a y-intercept of 5. So I'm going to take one of my points here, and I'm going to go on the y-axis up to 5, right there. Okay, and then I need to rise negative 2, which means to go down 2, and to run positive 3. 1, 2, 3. How do I know to go that way? Well, okay, y is positive up here. That's positive y. Positive x is over here. This down here, whoa, my airliner's out of control, is negative y. And then over here is the negative x, right? You got to pay attention to which coordinate you're talking about. It's not just a matter of this is the positive side, this is the negative side. It depends on which coordinate you're talking about. All right. Now I can get more points so I can draw a more accurate line. I don't know why my airliner is acting up. It was doing such a good job when I was getting set up. All right, so I'm going to go down 2 from that point and then right 1, 2, 3, negative 2/3. If I wanted to, I could have made the slope 2 over negative 3. They are the same number, just expressed differently. And from the y-intercept, I'm going to go up 2 and then left 1, 2, 3. And if you look, those 4 points are collinear. Like coworkers, Mr. Wenmouth and Mr. Lawrence are coworkers because we work together. These are collinear points, meaning they're on the same line. Okay, they're on the same line at the same time. All right, which at different times wouldn't make any sense. Now remember, how many points are on that line? There's not 4. No, 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 you silly person. No, there's an infinite number of points on that point, on that line. I'm just showing 4 of them. Yeah, that's all. I'm just showing 4 of them. Okay, there's points everywhere you see green. Everywhere you see green, there's a point there. Okay, in fact, there's not really a line. There's so many points, and they're so dense and so close to each other that they make a line. Yeah, they fall in that pattern that we call a line. All right, so let's go down here. Now in this one, I'm not in slope intercept. Oh no, silly Mr. Lawrence, because y is not alone. See that? It has a -7 or a 7 attached to it by subtraction. Here's where I'm going to use my equation solving skills and inverse operations to get y alone. So my first step is going to be say, well, what's keeping y from being alone? Well, the 7. How is it attached? Subtraction. What's the inverse of subtraction? Well, you silly person, you know it's addition. So I'm going to add 7. But if I do it to one side of the equation, I have to do it to the other. Now, do you notice I didn't do it to the 3x, right? 2 reasons. I wouldn't put the second plus 7 here because these aren't like terms. 3x plus 7 is not 10x. No, it is not. Don't argue with me, Tino. All right, 3x plus 7 is not 10x. They're not like terms. You can't put them together. The one's an x term and the one's a constant. But this -5 is a constant. Okay. Now some of you might think, well, wait, you're doing that wrong, Mr. Lawrence. You gotta do this. Oh, no, you silly person. No, if I do that, I've added 7 to the left-hand side of the equation. See it right there? And I've added 14 to the right-hand side of the equation. Why? Because I added 7 twice, right? Plus you're gonna combine unlike terms. So I definitely do not want to do that. So let me get rid of that plus 7 there. It does not belong. Go away. Okay, very good. All right, so I draw my little line. And then on the left-hand side, the 7s have canceled out. I get a y, 1y. Y's alone now. Yay, that was my goal. And I have 3x plus 2. Because -5 plus 7 is 2. All right, so the y-intercept is going to be 2. I should write this down. I should get this handy, right? The y-intercept, b, is going to be 2. And my slope is going to be 3, but I really like slope to be a fraction, so I'm going to make that as a 3/1. Yeah, I can't put it over any number. I have to have a fraction that when I divide, I get 3 for an answer. I could use 6/2 or 9/3, but it's just so much easier to put it over 1. So my y-intercept is here at 2 on the y-axis. And then my slope is rise 1, 2, 3, run 1. Okay. Rise 1, 2, 3, run 1. Okay. If I wanted to, I could be like really crazy and make them both negative. Because the two negatives, well, not a -3. No. Don't do that. Bad doggy. Okay. There we go, -1. If I do that, you say, well, don't the two negatives cancel out? Yes, but watch what happens with the slope. I'm going to go down 3, 1, 2, 3, rising -3, and then run -1, which means I go to the left. And look at that, those 4 points end up being collinear again. Yeah, they sure do. Yes, they do. Okay, so remember, I don't just play connect the dots. I'm drawing a line. The line should take up a good portion of the graph. It should extend very long because it goes forever, and it needs arrowheads to show the reader that it does go forever, right? We don't just go from here to here. We're not doing connect the dots. All right, now I need to show you how to do these on Desmos. So let me see, I think I've got Desmos ready to go right here. And the first equation was y equals -2/3 x plus 5. Okay, so I'm going to bring up Desmos, and I'm going to type in y equals -2/3. By the way, right here, I have to hit the right arrow so that I get out of the denominator. If I don't, all of a sudden my x is in the denominator and I don't have a linear equation. And then it was plus 5. Okay, now, I don't know why Desmos does this for its default, but its default is showing 2, 4, 6. So I'm going to hit the plus sign one time, so I'm zoomed in, and then I'm dragging, I'm clicking and dragging. And if you look right here, my y-intercept is 0, 5. There we go. And if you go back and look at my graph, dun, 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 that's the point 0, 5. Okay? Looks like my x-intercept is at 1, 2, 3, 4, 5, 6, 7, 0 right there. Let's go see if my Desmos picture is crossing the x-axis at 7, 0. Oh, it's not. It's not. My line must be a little bit inaccurate. The one I drew, it looks like that says it's 7.5, 0. So let me go see what's wrong with my line. I'm checking it. You know, sometimes the line is a little bit too fat, so I'm going to make it a little thinner. Okay. Put it on a diet. Where did it go? This is not a good time to act up on me in the middle of a video. All right, I'm going to make my line thinner. There we go. And let's see here. Let's make sure I've got all my points in the right place. 1, 2, 3, 4, 5. And then my slope was negative 2/3. And so I'm going to go down to 1, 2, 3. That's right. Oh, that one's off a little bit. Let me center it better. Okay, and I'm going to go down 2 and then write 1, 2, 3. All right. And sometimes it's a little finicky, so I'll try to get it as best I can and then make it longer. All right, so yeah, if you look there, it's not really going through it. It's not perfect, but so it's not actually going through 7, 0. If you see right here, it's close, but it's a little bit past it. Let's try this point. This point should be the point 6, 1. Let's go to Desmos and see if my line touches 6, 1. Oh my goodness gracious, it does. Look, it's right there. There it is. Okay. By the way, how am I doing that? I am clicking and holding the click on the line, and as I do that, notice it shows me several points. It doesn't show me all of them though, because there's an infinite number of points in here. In any little space along this line, there's an infinite number of points that you can't see. They're so densely packed, they look like what we call a line. But we can check other points too. If we look at this one here, it's at 3, 3, right? I guarantee you that this is going to be the point. Oop, what am I doing, silly Mr. Lawrence? The point 3, 3 is going to be right there. Bam. Okay? The one I just graphed was, I don't remember, was it y plus 4 equals, I better go back and look because I just don't remember. Okay, no, y minus 7 equals 3x minus 5. Okay, so y minus 7 equals 3x minus 5. All right, so here we have a line going this way. It's going up to the right. Okay, did our line do that? It sure did. It's going up to the right. And I'll tell you what, I'm going to learn my lesson and make that line thinner, so I don't embarrass myself again. Oh no, I lose credibility with students. Not good. Okay, so, yeah, I'm at school recording this video. All right, lucky you. You're at home in your PJs, eating your Captain Crunch. All right, so the y-intercept was 2, and on Desmos, it says the y-intercept is 2. Beautiful. Now, let's see if I can find another intersection. Looks like 1, 5 is on the graph. Let's see here. There it is, 1, 5. Okay, so let's see if I'm going through 1, 5. 1, 1, 2, 3, 4, 5. Yep, I sure am. If you are going through 2 points the same as Desmos, then you have the same exact line, even though your picture might look different. Okay, so that's how you use Desmos. I'm not going to check it on all of them because I want to get some more of these problems done. Anyway, so here's problem number 3. This time the y is not alone, but it's attached. It has a 4 attached to it, but the 4 is attached by multiplication, right? That's multiplication. So to undo multiplication, I'm going to divide. But remember, when you divide, you have to divide all 3 places. But no, Mr. Lawrence, you said in the addition one. Yeah, this is different. You have to divide the entire side by 4, which means you have to distribute the division. Yeah, you can distribute division. It's the same as distributing multiplication. All right, and so when I do this, I'm going to get y, because those 4's just canceled out, equals, don't make this hard. You see negative 5 fourths? Leave it like that. Don't turn it into an improper or a mixed number or a decimal. Leave it like that. You can count rise and run so simply. And then 12 divided by 4 is 3. So now my y-intercept is 3, and my slope is negative 5 fourths. And so I'm going to go to the y-intercept of 3, dun, 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 and I will go down 5, which would be here, and then to the right 1, 2, 3, 4, and I can do that again. I need to go down 5, 1, 2, 3, 4, 5, right, 1, 2, 3, 4, and then that little trick I did moving the negative, I'm going to rise 5 this time. 1, 2, 3, 4, 5, and left 1, 2, 3, 4. That is because negative 5/4 and 5 over negative 4 are the same number. Okay, so let me get a line going here. And you can check this one on Desmos. I'm not going to check on Desmos anymore. I know I'm doing it correctly, but you should definitely check. It'll only take you a little bit of time. This is just to help you with the recent assignment, or also Mr. Wemmett's kids have already started topic 6, and it's an essential skill to be good at if you want to be able to do 6. That's why I took a little time and reviewed it before moving into 6. We'll be starting 6 next week, Mr. Lawrence's kids. All right, there you go. Okay, let's do a couple more here. All right, now this one's going to give a lot of you trouble. This one has 2 numbers attached to the y. First of all, it has the 4, or you could even argue the negative 4, because remember, the sign belongs to the number it's in front of. But it also has the 5x. Yeah, not the 5, the 5x. 5x is a number. What number is it? It's 5 times whatever x is. So if you tell me x is 2, then this number is 10. If you tell me x is negative 3, then I know this is negative 15. Okay? So the 2 numbers are 4, or negative 4 actually, and then 5x. I need to think about them as numbers because the variable I'm solving for is the y. I need to get y alone to be in slope intercept, not get the x alone. So how is the negative 4 attached to the y? Well, it's multiplication, right? It's multiplication. And how is the 5x attached? Well, that's addition. No, it's not subtraction. That negative belongs to the 4. See how I highlighted it that way? Funny that I highlight blue, it turned black. That's very strange, but it's standing out, so that's good. Okay, so this is actually addition because the 5 is positive. If the 5 were negative, I would say subtraction. All right, so my inverse operations, I have to undo one with addition, subtraction, excuse me, and then undo with division. But which do I undo first? Well, you have to listen to Saddam. Listen to Saddam. We're going to undo subtraction and addition before we undo division and multiplication. Okay, that's the key here. So I'm going to get rid of the addition first, which is to subtract a 5x from both sides. I'm not going to line it up under the negative 16 because they're not like terms. I'm going to put it right here. Okay, so when I do that, the 5x's will cancel. I'm going to get a negative 4y equals negative 5x minus 16. All right. Now, y is not alone because it still has this negative 4 here attached by multiplication, which means I'm going to divide by negative 4. But I have to do multiplication or division. I have to undo that on all the terms. I'm distributing. Remember, I'm distributing. Okay, so I'm going to get y equals 5/4 x. Wait a minute, Carter, I didn't make a mistake there. Yeah, Carter raised his hand and he thinks I made an error. It's because there's 2 negatives, right? And those 2 negatives cancel out. See, and I get 5/4 x. A negative 16 divided by negative 4 is going to be a positive 4. There we go. Y is alone. I'm ready to find the y-intercept, and I'm ready to find the slope, and I am ready to graph. Okay, so I'm going to do this one kind of quick. Y-intercept is 4, and the slope is 5/4, so I'm going to have to rise 1, 2, 3, 4, 5, and then run 1, 2, 3, 4. Now you see why I showed you that trick before. I'm going to change both signs on this one because I'm out of room up there. So I'm going to rise negative 5, 1, 2, 3, 4, 5, and run negative 4, 1, 2, 3, 4. Okay, and if I want a 4th point, I'll do that again. 1, 2, 3, 4, 5. 1, 2, 3, 4. And there we go. The points are collinear. And I need to draw my line. I need to draw my line. I need to draw my line. And remember, you don't play connect the dots. Those aren't dots, they're points. They have names. One of the names is 0, 4. That's the Y-intercept, right? It has more than one name, that point. But they all have a name. The name is made up of 2 coordinates, and that's looking pretty good. Okay, number 5. You can check that on Desmos if you like. Number 5 is done very much the same way. I have 2 numbers keeping y from being alone. One is the 1/4, and the other one is the x. The 1/4 is attached by multiplication, and the x by addition. Not because of this, but because it's a positive x. So the first thing I'm going to do is subtract x. And again, notice I wrote it in front and I didn't line it up. Okay, so underline that, and I'm going to get 1/4 y equals negative x plus 2. All right, now I'm supposed to divide on this one, right? I'm not going to. I'm going to cheat. You see, I know something you don't. I know that 1/4 y is the same as y divided by 4. If I take a fourth of a number, like, give me a number like 12, I take a fourth of it, I'm going to get 3, right? If I break 12 up into 4 equal groups, each group will have 3. Think of 12 cookies, got to put them in 4 little baggies. Each baggie is going to have 3 cookies in it. If I take 12 cookies and divide by 4, don't I get 3? Right? Those are equal statements. 1/4 y equals y over 4. That is a true statement. It is always true. It's not sometimes true. It's not true on Sundays after 3 o'clock when it's raining. Okay? It's always true, which makes it incredibly powerful. So I think it's easier to think about that 1/4 y as y over 4. So I'm going to erase that part there and make it y over 4. Why am I going to do this? Well, now I have the 4 attached by division, which means I'm going to multiply both sides. I'm going to multiply this side by 4 over 1. You don't write this. No, 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 no. Bad doggy, do not do that. Do not do that. Don't do it. 4 times 4 does not cancel out. 4 divided by 4 cancels out. That's not division. Yes, it is. One's in the numerator, one's in the denominator. That's division. Now I also have to multiply both terms by 4. I have to distribute a 4 just like I did with the division in the other problems. So when I do that, I'm going to get y, because these 4's are going to cancel out. I have to do 4 times negative x. Well, guess what? That's negative 4x. And then 4 times 2. That's going to be 8. All right? So I know my y-intercept is 8. And my slope is negative 4, or better yet, how about negative 4 over 1? So I'm going to rise negative 4, maybe. Come on, points. Why don't you go? Oh, there it goes. Okay. It had some y going on. 1, 2, 3. Yeah, it seems too many. 1, 2, 3, 4. Okay. And then run positive 1. Okay. And I like the way my line's looking. Did you notice it's going down to the right? Remember, slopes that are negative have lines that go down to the right. I've told you that many times. If you've never heard that before, you're probably not telling the truth, but you should write it down. I'm only going to do 3 points on this one just to speed things up a little bit, and I'm not going to change colors and all that because this video is starting to get a little bit long. Okay, this is just a little practice to help you with what you have to do in topic 6 or Mr. Lawrence's homework assignment from Thursday. Oops, wrong place. Okay, one last thing I wanted to talk about, and it's these 2 problems maybe. Here, let me get back in arrow mode. Looks like my airliner needs a rest. It's giving me fits. I want you to pause the video and see if you can graph these 2. Mr. Lawrence's kids, we just talked about this. This should be pretty simple. But if you're not sure, go ahead and give it a shot. Okay? All right. I'm getting ready to show you the solution. Please make sure you've tried it on your own. All right. Now, the red one is in slope intercept form, believe it or not. You might not believe that, but it's y equals 0x plus 4. because there's 0 x's in the equation. Don't say no x's or none. There's 0 x's. So my y-intercept is 4, and my slope is 0, or 0 over 1. So I'm going to rise 0 and run 1. Okay, I'm going to rise 0 and run 1. And then I'm going to rise 0 and run 1. And then I will have to draw that line in. Come on, Liney. Come with me. There we go, Liney. Good, Liney. All right, and I better change the color so we can tell what's going on. Okay, and again, if you haven't tried the green one, go ahead and try it. Now, the green one is not in slope intercept form. Mr. Lawrence's students know that the rise and run, or excuse me, that a vertical line has no slope, right? And it usually doesn't have a y-intercept unless it's the y-axis, in which case the y-intercept is the entire line. So, how do I get this line? Well, I'm going to make an input-output table. Okay, I'm going to make an input-output table. I'm going to get 2 or 3 values, points, and then I will know what where to graph my line. Well, x is -3. How do I know? Because it says x is -3. What's y? I don't know, pick a number. Any number on the number line. How about 1? Yep, that's on the line. I guarantee it. Okay? Now, x is -3. How do I know? It has to be, because that says x is -3. I don't get a choice. Now, I'm not going to write 1 again. That'd be ridiculous. I do have the same point twice. I couldn't draw a line through that. So maybe I'll pick 2. Okay? Let's do another one. -3 for x. It has to be. You don't have a choice. Okay? What's y going to be? I don't know. Let's be creative. -5. Sure. Watch what's going to happen. Okay? So my first point is at -3, 1. My second point is at -3, 2. And my third point is at -3, -5. And there it is. Okay? And so you see I do get a vertical line. And it's true for a vertical line that every x-coordinate is the same number. What number is it? Well, if you know the equation, it's that number. If it's at x equals 7, the x-coordinate of every point would be 7. 7, 1, 7, 7, 7, -13, whatever. Okay? I don't know if you noticed on the horizontal one, the y-coordinate of every single point is 4. This is 0, 4, 1, 4, 2, 4, 3, 4, and look at the equation. Y equals 4. Yeah, it has to be that way. All right, that's it for the video. I hope this really helps. Please take some time. You don't have to watch it all at once, or you can watch parts of it over again. All right, Mr. Lawrence signing off. Have a good night, everybody.